The warm-up valve. The warm-up valve consists of a diaphragm, coil spring, bimetallic spring, and an electric heating element. With the engine cold, the bimetallic spring presses down on the coil spring, thus allowing the diaphragm to relax. In this condition, fuel from above the control plunger flows back to the tank unrestricted, which causes a low fuel pressure above the control plunger. This is called control pressure. As the engine throttle is opened, the airflow meter plate lifts, and likewise the control plunger lifts. However, because there is only a low control pressure above the plunger, both the plate and plunger lift more easily and slightly further, therefore increasing the amount of fuel delivered to the injectors. The mixture is therefore enrichened. All the time the engine is running, electrical current supplied by the fuel pump relay causes the warm-up valve heating element to heat up. This warms the bimetallic spring, causing it to slowly bend away from the coil spring. The coil spring can now exert a pressure on the diaphragm, and in turn, this gradually restricts the flow of fuel back to the tank. Control pressure in the line between the warm-up valve and the top of the control plunger rises and forces the plunger slowly down. This gradually leans off the mixture. The time taken for the warm-up valve to heat up is approximately 3 to 4 minutes. With the engine cold, the warm-up valve creates a low control pressure, therefore a rich mixture. With the engine hot, the warm-up valve creates a high control pressure, and so a lean, normal running mixture. Remember that the warm-up valve requires electrical current to heat it up, and not just engine temperature alone. Auxiliary air valve. When the engine is cold, it is also necessary to increase the idle speed as well as enriching the mixture. This increase in idle speed is carried out by the auxiliary air valve, which provides an additional air supply around the closed throttle valve. It consists of a rotary valve, bimetallic spring, and an electric heating element. With the engine cold, the rotary valve is opened, allowing additional air into the engine. This additional air still has to flow past the airflow meter, which lifts accordingly. With the valve in this position, the engine idle speed is increased. Once the engine is running, electrical current from the fuel pump relay warms the heating element, causing the bimetallic spring to bend and gradually close the rotary valve. The engine idle speed then slowly returns to normal. Normal idle speed adjustment is by means of a small brass screw, which, when turned, increases or decreases the small amount of air bypassing the normally closed throttle. Cold start valve. Good cold starting is achieved by the fitting of a cold start valve. This valve injects additional fuel directly into the inlet manifold when starting at engine temperatures below 35 degrees C. The cold start valve is supplied with fuel at system pressure from the lower chambers of the metering unit. Electrical current supplied from the starter circuit is used to energize and open this valve. The period of time that fuel is injected by the valve is determined by the thermo time switch. The thermo time switch. The thermo time switch is located in the cylinder head and screws directly into the cooling system. This thermo time switch provides an earth connection to the cold start valve, which is dependent on engine temperature and starter cranking time. Internally, the switch consists of a pair of bimetallic contacts and a heating element, which is supplied with current from the starter circuit. When starting at engine temperatures below 35 degrees C, the bimetallic contacts are closed, and therefore the earth connection to the cold start valve is complete. Whilst the starter is in operation, the cold start valve injects additional fuel into the manifold. At the same time, the thermo time switch heating element receives current from the starter circuit, thus causing the bimetallic contacts to open after a short period of time. This breaks the earth connection to the cold start valve and switches it off. The period of time that the valve injects fuel is between 1 and 8 seconds, dependent on engine coolant temperatures and starter operation. When the engine temperature is above 35 degrees C, the bimetallic contacts are held open by coolant temperature, and therefore the cold start valve is switched off. Improvements to the basic system. The transfer valve. One of the initial improvements made to the K-jetronic injection system was the inclusion of a transfer valve inside the system pressure regulating valve. When the engine is switched off, the transfer valve closes off the return line from the warm-up valve to the tank. This helps the accumulator to maintain holding pressure for a longer period of time, which improves hot starting even further. This valve is described in more detail in the self-study book. Full load enrichment. 5-cylinder engines are fitted with a different type of warm-up valve to provide additional enrichment during load and acceleration conditions. This is achieved by a second diaphragm inside the lower part of the warm-up valve and a vacuum connection to the inlet manifold. With the engine idling, or in the part throttle range, the low inlet manifold pressure keeps this full throttle diaphragm in its upper position to maintain spring pressure on the valve diaphragm. The control pressure is normal. However, when accelerating, the higher inlet manifold pressure pushes the full throttle diaphragm down, which reduces the spring tension slightly. This causes the valve diaphragm to relax and lower the control pressure, thereby enriching the mixture. That completes our look at the K-jetronic fuel injection system. As we have already mentioned, since its introduction there have been many changes to this basic system. These are all described in detail in the self-study books which accompany this tape. Future programs will explain the diagnosis and testing procedures required to trace and repair faults quickly and efficiently within the K-jetronic system.